We all know that an interpreted language is going to be slower than a compiled language, by and large, right? That's just a given. We all can think, oh, JavaScript is probably not as fast as the same function coded in hand-optimized assembly, right? Like, we all know that. As a programmer, we understand that. But when you really sit down and benchmark all of the major languages at performing the same basic tasks, and you look at the amazing difference in performance, it really begins to boggle the mind a little bit. Case in point, this was a study done in 2021 out of Portugal, and it concluded that Python as a programming language is 71 times slower at performing the same tasks than C. And this is crazy, uses 75 times more energy, more electricity. Actually, it's more than that. It's actually more like 76 times more electricity and 72 times slower, but I rounded down to make Python look better than it is. This is a fascinating study. I'll link to it here so you guys can all check it out. Let me read a little bit from the introduction here. This paper compares a large set of programming languages regarding their efficiency, including from an energetic point of view. Okay, they go on to say, we have taken rigorous and strict solutions to 10 well-defined programming problems expressed in up to 27 programming languages from the well-known Computer Language Benchmark Game repository. This repository aims to compare programming languages based on a strict set of implementation rules and configurations for each benchmark problem. Now, let's take a quick look here. Let's scroll down here. They've got a list of some of those. They talk about how they measure the electricity and whatnot, and how they go through it. And they run all of these benchmarks with all of these 27 different languages, same basic functions on the exact same machine, and they measure it and how they measure the electricity and the performance and the memory usage and all of it, which is absolutely fascinating. But scrolling down here, they've got a list of... Hey, why don't you have this ready already? Here we go. There it is. Of the various benchmarks, right? They've got a Mandelbrot set, an N-body, do double precision N-body simulation, generate and write random DNA sequences, allocate and traverse and deallocate 21 binary trees. Like, they have a number of these different things. Something that... by and large, most programming languages are capable of and are going to be done sometimes, right? They all kind of exercise each of these individual languages in slightly different ways. So having a nice diverse set of these different benchmark functions should give a nice, well-rounded impression of how fast these individual languages are. Now, one of the things that these benchmarks don't take into consideration is calling external native functions written in different languages from another language. For example, if you write a Python program, you can call out to a function written in C, and this doesn't really benchmark that. It's the pure language compared to pure language, right? So let's scroll down here. It goes over all the different languages, and it's got everything from Dart to TypeScript and Perl and C and Ada and Erlang and Ruby and Perl and Haskell, and there's just tons and tons of stuff in here. But where it really gets crazy is when they break it down. Here we go, page 15. There it is. No, wait, is this it? No, not quite. There it is. Here it is. We've got the normalized global results for energy, time, and memory. So they take all of the results from all of the functions run from all of the languages and measure them, right? And then they rank them all from fastest or most energy efficient or uses the least amount of memory. They set whatever language was the fastest as the base mark, right? As the very baseline. And they gave that one a value of 1. Everything else is how many times slower or how many times more energy does that one use. So for example, Rust is slower at all of these tasks by and large than C. Not a lot though, right? So C is the fastest. The fastest of all these languages was pure, plain old C. God bless it. Rust was a little bit slower. So where it was just a 1.0 for C, Rust was 1.04 times slower than C. So, I mean, you can see it's really, really close, neck and neck. The same was true for energy consumption with Rust. Rust uses more electricity than C. It uses 1.03 times the amount of electricity that the exact same functions written in C would use. So is Rust slower? Is Rust more energy inefficient? Absolutely. Interestingly, Rust also uses quite a lot more memory than a lot of other functions. We'll get into the memory, or a lot of other languages. We'll get into that in a second, though. But what really blew my mind was, let's look at the performance here. And if you scroll down the list, for those of you listening to the audio podcast, go check out the video version so you can see the list, or bring up the PDF here. Lua, of all the languages tested, was the slowest. Holy smokes. So a function written in C, okay, or all of these functions benchmarked in C, Lua was 82.9 times slower than C. 82.9. Now, I mean, that's a given. Lua is very high level. It's interpreted. It makes a certain amount of sense. JavaScript was 6.5 times slower than C. Okay, yeah, that again, it kind of makes sense. JavaScript's going to be slower than C. The one that really got me was Python, right? Because as a Linux user, you see a lot of Python. There's a lot of scripts and applications written in Python on all of the major Linux desktops. And sometimes you don't even realize how much stuff is written in Python. Python is 71.9 times slower than C. Holy heavens. I mean, that's off the charts. Perl is 65 times slower than C. Ruby, people are like, oh, you got to use Ruby and Ruby on Rails and all these other blah, 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 blah. Ruby is 59 times slower than C. TypeScript is 46 times slower than C. PHP is only 27 times slower than C. Dart, 6.6 times slower than C. All of these things, Java and C++, everything is slower than C. Everything is slower than C, which makes you think, well, why are people just using straight C more often, man? But let's look over at the energy consumption side. Now, the energy consumption, there is a direct relationship with the amount of time it takes to run something and the energy consumption, but that's not the only impact. How your system is operating, it will use a different amount of energy. And they measured these in joules and of actual joule usage, and measured all of these languages running the full benchmark suite and listed them out. What's amazing here is Perl was the most energy intensive of all the languages, using 79.5 times more electricity than a comparable program written in C. Ruby uses 69 times more energy than C. Now, if you'd think if someone's all worked up about, energy consumption and energy efficiency and the climate, the environment, whatever, you'd think, well, they just write everything in C. I'm going to say this flat out. If anyone's out there and they're like, oh, we got to save the environment, we got to use less energy and electricity, we got to make energy efficient this and energy efficient that. If they're not writing all of their software in pure C, they don't care that much about the environment or electricity usage. Clearly. I mean, look at this. Where's Swift at? Swift uses 2.79 times the amount of electricity of C, right? And it runs 4.2 times slower than C. So I see a lot of people writing a lot of software in Swift lately. Oh, okay, but your software is probably going to run slower than it could. And it's going to use several times more electricity than it could. Take that and multiply it by 1 million users, and you've necessitated that we fire up a whole nother power plant. So if you actually cared about electricity usage or energy usage, you would just use C. I'm just going to put that out there. So next time I hear any programmer or computer nerd talking about environmental issues or global warming or energy consumption or whatnot, and I find out that they're using any language other than C, I'm just going to show them this chart and show them that in all practicality, they don't care either. Okay, let's look at memory usage for a second, because this is actually a little bit fascinating. C was not the winner in this regard. The programming language where the compiled running software used the least amount of memory was Pascal. Yeah, baby, Pascal. Pascal was the baseline for memory usage. Everything goes up from there. Now, C did well. C used 1.17 times the amount of memory as a comparable Pascal program. So it was just a little bit more. But man, you go down the line, the worst offender was JRuby. JRuby used almost 19.8 times the amount of RAM that a Pascal program used. But again, Dart and Erlang and Lua and Java, I mean, they were all using 6 or more times the amount of RAM for just a simple benchmarking program. And this isn't even including crazy UI frameworks and all sorts of other things. This is just running really just CPU intensive basic computing tasks, right? That's what this is measuring here. And oh my word, the amount of RAM these things used. C# used 2.85 the amount of RAM of Pascal. Where's Rust on here? Rust used 1.54, so 1.5 times the amount of RAM of Pascal. That's crazy. That's crazy. Now I wanna preface all of this by saying that realistically, we're gonna find some variations in these numbers if we did a variety of benchmarks ourselves. For example, I know for a fact that the free Pascal compiler, under certain circumstances, significantly outperforms a wide variety of C compilers, including GCC. The free Pascal compiler it's a very fast multi-architecture compiler. And I know that depending on which compiler you use, which compiler settings you use, and exactly which task you're using, you will find different results here. But these are the results that this group found, and they averaged them out among all of the different benchmarks. So my guess is they're by and large generally in the right range. I would argue that if I sat down to do these same benchmarks, the numbers would probably be a little different. Maybe a couple of them would jockey for position 1 or 2 spots here and there. Probably the same would be true for you. And if we did them on different machines, whether it's an ARM architecture or RISC architecture, or even just a slightly different x86 or AMD 64 machine compared to what they used here, we'd probably get a little bit different results. That's just how this sorts of thing works. But I think this pretty much drives the point home that C is significantly faster than all of these, and 75 times more energy is used when you use Python. 72 times slower than C. Oh my heavens, oh my words. There's a number of charts in this. I recommend reading through this. It measures everything else and provides a number of different charts for how they measured everything, the speed and the joules usage of different functions, how much energy was used. They actually break it down, how much energy was used by the CPU versus how much energy was used by your RAM. They actually measured all of this and they broke it down in the charts. Like for example, for the binary tree benchmark, they measured it out, and you can see that the Lua benchmark used a ton of memory for RAM that the other ones just didn't use. It was fascinating. There's a few other ones like F#, Erlang, and C# all used a lot of memory for the RAM. C and C++ and Fortran and Rust really didn't use a whole lot of any memory in the RAM. It was all in the CPU. And even then it was really, really limited because it ran so fast and really didn't tax the CPU all that much. It's fascinating when you go through all this. They've got all of this charted out. They really did a great job of benchmarking all of this. Again, I'm pretty sure They went through everything. You can see exactly how the energy and time correlations and they measured everything out. They've got all the data here, so you can go in and kind of recreate it and create the charts yourselves. A really, really excellent job to the people who put together this study. But just the same, fascinating. I wonder if going forward, how much worse this situation is going to get. Because we see a continually exploding amount of both speed degradation, extreme memory usage, and energy usage in new programming languages that are coming out. Notice none of these new programming languages that have come along in the recent years, like Swift or Rust, have made things faster. They've all made things slower. They've all made things use more memory, and they've all made things use more electricity, right? They're not using more electricity and getting faster. No, they're using more electricity and getting slower and using more RAM. There are no instances where newer languages are making things faster or more efficient or in any possible way, right? Like that's just not a thing that's happening. So what boggles my mind is why, right? Do we really not care about speed or energy efficiency or memory efficiency anymore? Like, do we just not care at all? It seems that way, because even in the languages that are most touted for, oh, I'm going to make my software fast, like Rust, it's all slower. It's slower. It's not a lot slower, but it's a little slower. So the fastest of the new languages still makes things slower. So how does this progress? Looking forward, now I'm not here to tell you that C is the end all be all of languages. It's not. I mean, I like C. I've spent a lot of years in C and embedded systems and desktop systems. I like C. But is the end-all be-all system? I mean, it can't possibly be the greatest programming language ever, right? I mean, it's been around forever. It's not the oldest programming language, but it certainly is, up there in age. So clearly, we can create new languages that should be able to be faster. We should clearly be able to create compilers for some of these newer languages that should be able to make faster code, but we don't. So extrapolate this out. Flash forward many years, and what do you have? You have an environment where the languages themselves, not just the programmer laziness, not just our intense reliance on massive frameworks and libraries, slowing things down and creating massive code bloat, but the languages and compilers themselves are fundamentally slowing down our computer systems. That is a baffling thing to me, that is really going on. It seems like if we have so many programmers out there that are becoming reliant on these massive frameworks and this JavaScript framework over there and that Swift thing over here and these Objective-C libraries, these kits over there, like if they're really piling all this on and creating these massive code bloat where the software is getting so substantially larger in order to make the programming time faster, right? If we're really going that route, why are we not seeing a similar investment into building up the speed and efficiency of the compilers and the frameworks? We're really not. In fact, we're seeing things get progressively slower, and you can see that. I mean, I think anyone who would make the argument that, oh, we're doing an investment in compile speed and everything else, like no, that's really not happening. We have the charts. We can look at when these programming languages came about and when the last significant revisions were made to the compilers, and we can really look at them and say, no, things are getting slower across the board. Do we really want to think that 10 years from now, when all of our software is written in Python and Swift and Ruby and whatever else, that our systems are all going to be 71 times slower? Do we really want that? Do we really want that? I'm going to argue that we don't. And this is ridiculous. This is utterly ridiculous. So, takeaways from this. C is great, but also Pascal is pretty great. And Python, unless it's just a quick script maybe don't use Python, right? Like, I get it. You know, there's certain operations, a little quick script, whether it's written in Python or Bash or Lua or Ruby, writing together a little quick script to automate a bunch of commands, great. I see no issue in that. But once we're getting into compute-intensive things, we need to be at least having some eye towards speed and energy efficiency and whatnot. If we're really looking to increase the battery life, let's say, of our laptops or our handheld devices, the more Python we've got on them, the less battery time we've got to use our systems, right? If our Python script uses 75 times more energy than a similar thing in C, do the math on that. The more things you've got using Python on your system, the less time your battery is going to last. That's just basic science, engineering, and math there. So if we're really looking to increase the battery life of our machines, we should be moving away from things like Swift. We should be moving away from things like Ruby and Python and Lua, and we should be moving more towards things like C and Rust. I mean, let's bring this chart back up here real quick here. Rust is good in that regard too. I mean, sure, Rust is, not as good as C, but it's still good. Same with C++ and Ada. And you know what honestly is kind of surprising? Java. For all the bloatedness of Java is roughly 2 times slower than C and uses 2 times the amount of energy as C. But that still puts it significantly ahead of all of these other languages like Dart and Go and Swift and Erlang and Lua and Ruby and Python and Perl. It's significantly ahead of all of those. So I would say, realistically, you know what? I would put certain languages, C++, C, Pascal, and yes, unfortunately, even Java a little bit, as ahead of most of those other languages in terms of if we're really worried about battery life, energy consumption, and speed, we should be using those languages. I mean, just based on these stats. Now, after I post this, there's going to be a lot of people who are going to be like, this information is wrong. I'm going to compile with this language and it's going to be this times faster than that language and this is crazy. Fair. Again, you putting up together a benchmark on your system using a variety of different benchmarking tools and compilers is probably going to come up with somewhat different results from this. But these results do seem somewhat in line with what common sense dictates and what anyone who's used more than 3 or 4 of these languages in a professional capacity probably has witnessed in their actual shipping software. So it's not that far off. It really doesn't seem that far off. Anyway, I think this is fascinating. I want to say thank you to all of the Lunduke Journal subscribers for subscribing to the Lunduke Journal and making it all possible. Go to lunduke.com or lunduke.locals.com. Subscribe. Keep the lights on at the Lunduke Journal because otherwise there would be no lights, and that would be sad. And with that, ladies and gentlemen, boys and girls, nerds and nerdettes across the inner tubes, I do declare, end broadcast.